Precal Lecture for Pre-Calc at 7.1.3. It says the definition of a limit. So, further adventures of Benny and Bertha Bug await you in this lesson as the approach to one-sided limits is formalized. You will also think about limits when given data in a table rather than a graph. Let's get it bigger. There we go. Okay, where do we think we are going? Benny and Bertha plan to meet their friend Sally Snail. Sally's currently located as shown on the diagram at right. So there's a snail, and here's Benny and Bertha. And it says Benny starts at a point on the curve to the left of Sally Snail and moves along the curve to the right. Where does he think he will end up? So he's on the curve and he moves to the right, and if he follows the curve, it looks like he's heading towards Sally Snail. So it says he thinks he will end up at Sally Snail's current location. I know, this is kind of weird. Bertha starts at a point on the curve to the right of Sally Snail and moves along the curve to the left. Where does she think she will end up? Well, if she's on the curve passes right by Sally Snail, so she probably thinks she's going to end up where Sally Snail is. Unbeknownst to Benny and Bertha, Sally Snail plans to get her shell shined today. Since she moves so slowly, she's already on her way to her appointment. Sally Snail has moved. How does this impact where Benny and Bertha each think they will end up? Well, even though she's not there anymore, they're both heading on the path that led to her location, before she moved. So it says it doesn't impact their thinking. They still think they'll end up at Sally Snail's old location. Does the limit exist for the situation in Part C? That is, do Benny and Bertha predict they will arrive at the same location? Well, the answer is yes. The limit exists because Benny and Bertha both think they're going to the same place. So if you can approach a limit, if you're going along a curve from the left hand, if the left hand limit and the right hand limit are both at the same place, that's when we say the limit exists. Let's keep going. It'll make more sense as we keep going. Okay, so does the limit exist? Use the graph of y equals f of x shown at right to complete the parts below. Benny starts at the point 1, 3 and moves along the graph y equals f of x to the right. He's 1, 3. He's going to move to the right. At what y value does he think he will be at when x equals 3? X, 1, 2, 3. I think he thinks, so if he starts up here, see, because it said 1, 3, so he must start here. Where does he think he's going to end up when x equals 3? This is x equals 3 right here. I think his y value is going to be 2. And that's why it says he thinks he will be at y equals 2. Did I draw that bug? Look, I drew that bug, I think. Let's get rid of that bug. Alright. Bertha starts at 5, 1. So this is like 1, 2, 3, 4, 5, 1. So there's Bertha. And she moves along the graph to the left. So she's heading to the left. At what y value does she think she will be at when x equals 3? Well, I think she's also gonna think that she's at 2, at y equals 2. Write the limit statements for Benny and Bertha Bug as they approach x equals 3 from both sides. So see, they're both heading toward the same place. So it's just like the Sally Snail thing. So we would say something like the limit as x goes to, where was it, 3, and I'm not going to say from the left or from the right. If I just leave it blank, it means from either left or right. Oh wait, they're going to have me do that later. Equals 2. Sorry. So this limit right here, this would be the limit like which includes both of them. But if I want to do the limit for this bug over here, Benny, then I would write it this way. Benny, as he approaches x from the left, the y value is going to be 2. As Bertha approaches x equals 3 from the right, the y value, that's what f of x means, is 2. So hopefully that makes sense. This is a one-sided limit approaching from the left, and this is the limit approaching from the right. Since they both equal 2, I think in the next problem it's going to ask us to write the limit like this. So it says, notice there's a hole in the graph at x equals 3. Does the limit as x approaches 3 exist? If so, what is the limit of f of x as x approaches 3? Explain your reasoning. Well, the limit still exists because even though Sally Snail moved, like she went away to get her shell shined or whatever, following the curve, well, it's not really curvy, but following the graph from the left as x approaches 3, it leads to the same place as if you were to follow it from the right as x approaches 3. If it leads to the same place from both the left-hand and right-hand sides, then we could say that the limit exists. So it says, yes, the limit exists because both Benny and Bertha think they will end up at the same place, which is the limit as x approaches 3 of f of x is 2. It just means they're both heading, as far as the y values go, they're both heading toward 2. Letter E says, suppose you gently pick up the bugs. Where should you place each bug if you want to evaluate the limit of f at x equals 1? Well, there's a problem with x equals 1. So I could put Benny, if I want him to approach from the left, he'd be sitting right here. That's why I had that bug written right there probably. There's a little bug, a new bug. So I would put Benny right here because he wants to approach from the left. And then I would put Bertha up here because she's going to approach from the right. And so it says one bug should be placed on y equals f of x for x is less than 1. So see how x is less than 1? That's where I'm going to put Benny. Because that's the only way he can approach 1 from the left is if he's on this part of the curve. This part that's the left of 1. And then, or less, to the left of 1 means it's less than 1. And then the other bug would have to be on this part of the curve so that they can approach 1 from the right. And so that's where y or x is greater than 1. And then it says, use the graph to complete the following limit statements. So what is the limit as x approaches 1 from the left of this f of x? What's the limit as x approaches 1 from the left? Well, this bug, if he starts climbing up this piece of the, oh, you can't see. This bug, if he starts climbing up this piece of the graph and he's heading toward x equals 1, he can see that he's the point that he's going to get on the y-axis is just going to be 2. So he thinks he's going to 2 if he approaches from the left. But if he approaches from the right, he's going to have to be on this part of the graph to approach x equals 1. So he can see that his height, or his y value, is actually going to be 3. And if I don't put a plus or minus on it, it wants the limit as I approach, you know, from both sides. Like on this one, not on this one. On this one, the limit as I approach it, they're both going to the same place. If I approach from the left or the right, I still get to the same place. This one, if I approach from the left or the right, well, from the left I'm going to get to 2, but from the right I'm going to get to 3, so I have to say it does not exist. So this limit does not exist. I can't say whether it's, I mean, is it 2, is it 3? If it's not the same number, you write D and E. And then it says, letter G says, in your own words, explain when a limit exists as x approaches a number C and when a limit does not exist. So the limit exists if the bugs think they're going to end up at the same place when approaching x equals C from each side. So, like, for example, in this graph right here, the limit as x approaches 2 does not exist, because if I approach 2 from the left, I'm going to end up at like 3, and if I approach 2 from the right, I'm going to end up at 6. So that does not exist. But if I want to look at maybe this part of the graph, and let's say, what's this, -1, -2. So I could say the limit as x approaches -2 from the left and from the right. It's still, in both cases, they're going to end up at this spot right here, which is -1. So that limit would exist. I'll make another video just to finish off the rest of the problems. I'll call it part 2.